So direct variation seems kind of is a linear function that can be written as y equals kx, where k is the non-zero constant. So this formula is y equals kx. The constant of variation is the constant ratio of y to x in the direct variation. The constant of variation is your k. Constant of variation is another name for rate of change or slope. Constant, rate of change, slope, all mean the same darn thing. Welcome to math. So we are going to be determining whether the data they give us, possibly in different forms, shows direct variation. Okay, so here we go. We have some ways we can do this. They give us a table of Adam's growth chart in age and length. His age in months and his length in inches. Okay, so the first method we can do is we can make a graph that shows the relationship between Adam's age and his length. So we can go through, this is our x and this is our y. Okay? So our x is 3, our y is 22. 6, 24. 9, 25. And 12, 27. And we draw a line. Okay? Now, the next thing we can do is we can compare the ratios to see if direct variation occurs. So we can take any two points on Adam's growth chart. So they took this one and they took this one. And they put y over x. Okay, so they found the rate of change, so y over x. So they had 22 over 3 equals 27 over 12, and then they wanted to see if those two were proportional. So they cross-multiplied. 3 times 27, and got 81, and 22 times 12, and got 264. 81 is not equal to 264, so the ratios are not proportional. Both methods show that the relationship of the data is not a direct variation. Okay? Method 2, because they're not equal to each other, 81 and 264 are not the same number, but method 1 has to do two things. For method 1, you have to have a straight line, which we do, but the second rule is through 0, 0. It does not go through 0, 0, so that is not a direct variation. That data is not direct variation. Because when a baby is born, it can't be 0 inches tall. That's nothing. Okay, it has to be some length. Okay, the next type is find each equation of direct variation given that y varies directly with x. So, y is 54 when x is 6. Now our direct variation equation is y equals kx. And it tells us that y varies directly with x. Okay? So, we can substitute x and y. It tells us y is 54 and x is 6. Now this looks like 54 equals 6x. Okay? Now we need to get our k by, I'm sorry, that's not an x, that's a k. I'm just so used to putting x down. Now we need to get our k by itself to find out what the constant is, so we divide each side by the coefficient of 6, and our k is 9. So we solve for k. So anyways, y equals 9x. All we do is we substitute what k equals back into the form of y equals kx. So k equaled 9, so we keep our y equals 9x. So x is 12 when y is 5. Y varies directly with x. So we're going to substitute in x and y. Y is 15, x is 12. So that is like saying 15 equals 12k. To get k by itself, we have to divide by the coefficient. And when we simplify 15 twelfths, we can divide each by 3. And we get 5 fourths. Okay, so y equals, put in k, 5 fourths, leave it as an improper fraction, x. So we're going to substitute 5 fourths in for k in the original equation. So you're going to do number 1, you can either graph it, or you can set up a proportional relationship and see if they're proportional. And then 2 is like example 2.